Welcome to my channel. In the class 10 real numbers part 4, we will see the first sum. Prove that root 5 is irrational. Let us assume root 5 is rational. So we can represent by integer a and b not equal to 0 such that root 5 is equal to a by b. Suppose a and b as common factor other than 1, then it is not co-prime. Let us assume A and B are co-prime. So B root 5 is equal to A by B, or B root 5 is equal to A. Squaring, we have 5b squared is equal to a squared. We know from this a squared as a factor 5. Then by theorem 1.2 we know a as a factor 5. Now let us assume a as a factor 5. So let a is equal to 5c. Here a as a factor 5 where c is any integer. C is any integer. Substituting this in this, we can substitute in this, then it becomes 5 squared is equal to 25c squared. Here 5c whole square is 25c squared is equal to, which can be written as b squared is equal to 5c squared. So b squared as a factor 5, hence b as a factor 5. So since both have a factor, a and b have a factor, common factor 5 other than 1, a and b are not co-prime, which contradicts our assumption, because root 5 is not rational, that is irrational. First, sum or difference of rational and irrational number is rational. Rational and an irrational number is irrational. Let us assume three plus root 5 is rational. 2 root 5 is rational. Then 3 plus root 5 can be expressed as a by b, where b not equal to 0. Rearranging, we can rearrange this. Three minus a by b is equal to 2 root 5. Let us take this. Here 3a and b are integers, hence rational. So 2 root 5 is rational. This contradicts 2 root 5 irrational. Hence 3 plus 2 root 5 is irrational. First, remember the product and quotient. Product and quotient of a rational and irrational number is irrational. We have to prove that 1 by root 2 is irrational. Let us assume 1 by 2 is rational. Let us assume 1 by root 2 is rational. Hence, we can represent it in the form of a by b. Hence, it can be represented as a by b b not equal to 0. So 1 by root 2 is equal to a by b, or b by a is equal to root 2. But b and a are integers, hence rational. So b by a is rational means root 2 is also rational. Root 2 is also rational, which contradicts our assumption. Contradicts so 1 by 2 root 2 is irrational. Next, prove that the following irrational. 6 plus root 2 has to be proved as irrational. We know that sum and difference of a rational and irrational number is rational. Sum and difference of a rational number and an irrational number is irrational. Now let us assume that 6 plus root 2 is rational. Let 6 plus root 2 is rational. So it can be expressed as p by a by b. That is 6 plus root 2 is equal to a by b. Now we will rearrange. That is, we will take the 6 to the other side. That is, a root 2 is equal to ab minus 6. We will take the right hand side. A, b and 6 are integers. So a by b minus 6 is rational, which implies root 2 is rational. Which implies which contradicts, this contradicts so 6 plus root 2 is irrational. Next we have to prove that the following are irrational. 7 root 5. The first you have to remember that the product and quotient of non-zero, rational and irrational number is irrational. Product and quotient of non-zero, rational and irrational number is irrational. So let us assume 7 root 5 is rational. Let 7 root 5 is rational, so can be expressed as a by b not equal to 0. So 7 root 5 is equal to a by b. We can rewrite it as root 5 is equal to a by 7b. But on the right hand side, a, b, 7 are integers. A, b and 7 are integers. So rational. That implies root 5 is rational, which implies root 5 is rational. This contradicts hence 7 root 5 is irrational. Thank you very much. You should have understood the problem and solutions. If you have any doubts, put it in the comment box. We'll come up with the doubt clearing video. In the next series, class 10, real numbers part 5, we'll continue with the further sums. Thank you very much.